Is it an angel? No, it's an angle. But they're both still pretty awesome. So we're going to go through lesson 21.3 today. Third part of lesson 21 on angle relationships. And it's really wrapping up what we learned in the last two lessons. So we're still going to have the same learning target to find missing angle measures when parallel lines are cut by a transversal. So remember, parallel lines are lines that never cross. And a transversal is just a line that crosses through, that cuts through um, two or more other lines. And we've got lots of different types of angles that we've been talking about, and we're going to talk about some more corresponding alternate interior, alternate exterior, vertical angles, same side interior angles. Those are the main types of angles that we've been working with, and we're going to continue today. So here's a quick recap of what we learned. So we've talked about, and these are all true if two parallel lines are cut by a transversal. So there's a few examples where we have parallel lines and then a transversal, or more than one transversal. But I just want to give some examples. So let's just talk about vertical angles first. So remember, vertical angles are angles that are like, let's just say angle 9 and angle 11. So they're in the same intersection, but they're across from each other. So those two angles right there. All right. Um, those two angles are congruent. So vertical angles are always congruent. So that's important to know. Another example could be like angle 8. What would be congruent to angle 8 if they're vertical angles? That would be angle 6. Okay, so those are just some examples. They're not all of them. There's lots of examples on here. There's actually like 8 of them. Let's look at some corresponding angles. Now, corresponding angles are also congruent if we have two parallel lines and a transversal. So there's our congruent symbol. Let's do a couple examples of those. How about we start with angle 9 again? Corresponding just means it's in the same spot in a different intersection. So they correspond, they go together. Angle 13 would be an example of that. So angle 9 is congruent to angle 13. Let's do a different example. Let's just say, what about angle 10? What's a congruent angle to angle 10 by corresponding? You could say two different examples, actually. 14 or 6. 6 is also in the same spot in the lower right corner, just of a different intersection. So we'll say angle 10 and angle 6. All right, so those are corresponding angles. But alternate interior angles. Alternate interior angles are those angles that are on opposite sides of the transversal, but they're still on the inside of the parallel line. So let's just say we have like angle 15. Angle 15 is on the inside of this parallel line. So the other line to that would be this one. So we're looking at these two intersections. So the other one, the one that's alternate to it would be angle 9. And those are going to always be congruent. So we talked about that last time. So angle 15 is congruent to angle 9. Let's do one more example of alternate interior angles. Let's say we had angle 13. Now that looks like it's on the exterior unless we talk about this line and this line. So it's on the interior of those two parallel lines. So the alternate one would be angle 3. So angle 13 is congruent to angle 3. So that's just, again, one example. Let's look at alternate exterior angles. Same idea. We have to have one set of parallel lines. And same idea, they're going to be congruent as well. So I'm going to put the little congruent symbol if we have two parallel lines. But let's just say we have angle 10. Depending on which lines you're looking at, it could be on the interior or the exterior, but for it to be the exterior, it has to be the outside of this one and this one. So another one that's on the opposite side, but on the exterior would be 16. So they're the opposite sides of that transversal, but they are on the exterior of the parallel lines. But those are congruent to each other. We could also say, like, angle 1. If we're looking at this one and this one, angle 1 is on the outside, that would be congruent to angle 15. So those are examples of alternate exterior angles. And last reminder here, um, last one, same side interior. That's the only ones that we've been learning about that are not actually congruent. Those are supplementary. They add up to 180 degrees. Okay, so let's just look at an example here. Um, so same side interior means they're on the same side of the parallel lines and on the inside as well. So let's just take two parallel lines. Same side and on the interior. So 14 and 9. Those are not congruent, but the measure of angle 9 plus the measure of angle 14 equals 180. And we did a thing where you can kind of show that. Like if I took, let's just say I take this, get rid of that, get rid of that. I take this angle here, and then I move it over next to 14. They're right up against each other, and together they form a line, and we know lines make 180 degrees. So together those two form a line, so they are supplementary. That's a way to show it. Let's do one other example of a pair of supplementary. We could do like 7 and 10, same side of these two, of the transversal and on the inside of those two. So the measure of angle 7 and the measure of angle 10 are also supplementary, so they add up to 180 degrees. Those are lots of different types of angle pairs, but if you know their relationships, it's really easy to figure out other angles, even if you just start with one. So that diagram came from our last lesson, but let's look at some examples. In your notes book, this is on page 196 in your notes book. All right, green pages. So let's look at example number 14. The diagram shows lines L, M, N, P, and Q, all cut by one transversal. So this is our transversal T. All right. We don't know necessarily which ones are parallel because they don't all look parallel. Some of them look like they might be. But it says which two lines are parallel and how do you know? So if two lines are parallel, we'd have to know one of these things. We'd have to know like corresponding angles, alternate interior angles or alternate exterior angles congruent, or we'd have to know same side interior angles are supplementary. So they're all on the same side, but I don't think right now none of those look like they add up to 180. Um, but there are some things we can do to figure out, you know, like what ones would be like if I look at this. I know these are vertical angles, so this is 60 degrees. That doesn't really help me. There's no other 60-degree angle. Well, there's one right here, but that's not any relationship. There's no alternate interior, exterior, or corresponding angles. There's no same side interior. So let's look at, well, that would actually be 120 right here then. How did I figure that out? Well, I know that a line is 180. So 180 minus 60, 0 to 1. So it's 120 degrees right there. So then I know 120-degree angle and 120-degree angle, they're in the corresponding parts. So that means that those two lines that they're touching, line P and line L. So line L, and that's a cursive L right there. That's what they use for lines, is parallel to line P. And how do I know that? Because corresponding angles are congruent. So it's kind of tough. There are some things you had to figure out there and some specific angles you had to look for, but we found some corresponding angles that were congruent. Let's go to number 15. It says Airy drew the two lines P and Q and a transversal line T that's perpendicular to Q. So that would mean angle 1 is 90 degrees. Okay, it's a right angle. He says since angle 1 and angle 2 are corresponding angles, which they are, they're in the same spot, just in a different intersection, then angle 1 and angle 2 are congruent, and so then that has to be 90 degrees as well. But I don't think that looks like it's a right angle. I mean, just looking at it, it doesn't look like it's a right angle, right? Oh, come on. I don't think it is. Um, but when he measures it, he finds it's 75 degrees. So what was his mistake? Did he find his mistake? Well, there's one big thing that we've been talking about with angles when like corresponding angles or alternate interior, alternate exterior are congruent. There has to be two parallel lines cut by a transversal. We don't know that P and Q are parallel. It doesn't say that anywhere. It doesn't look like they're parallel. In fact, it looks like they're going to cross like right there. So basically, in order, or we'll say it like this, in order for angle 1 and angle 2 to be congruent, lines P and Q would have to be parallel. But they are not. So if they're not parallel, then those angles are not congruent. We can't say that because we know that there's not two parallel lines cut by a transversal. All right, last one we're going to look at actually is number 16. In the diagram, parallelogram ABCD, we have ABCD and it's a parallelogram. That means that opposite sides are parallel. So I'm going to draw these little arrows to show that they're parallel. If you've ever seen those before, that means like two arrows here. It means it's parallel to the two arrows there. Write an argument to support that angle X and angle Y are equal. Okay. Well, we have parallel lines right here and right here. I can ignore the side ones because X and Y are touching those ones. And guess what? We have a transversal. I can write that. We'll try. Um, so if we have two parallel lines and a transversal, why would X and Y be congruent? What type of angles are they? Angle X and angle Y are alternate interior angles. And they are formed by two parallel lines with a transversal. Whoops, lines, not lies. So, angle, whoops, angle X would be congruent to angle Y, or their measures would be equal. All right. Now, if you want to try the last activity on the next page, you can try that. It's very like hands-on way to kind of play around with what we've been talking about. It can be hands-on, but it also could be. I mean, it's an application of what we're looking at. So with patterns, I'm not going to go through that right now, but you can try that one on your own if you'd like for some more practice. But I think what we did today really kind of summed up and reviewed what we're talking about with finding missing angles when we have parallel lines cut by a transversal and looking at the different type of angles that we have there. So we're going to end it with that. That's our last part of Lesson 21, Angle Relationships. We'll see you next time.